Hello, everyone, and welcome back to Unity's live stream. I promised you all last week that we'd be talking about graphics and render pipelines this week. So that's what we're going to do today. We'll be talking about URP specifically, which, if you're unaware, stands for the Universal Render Pipeline. At Unite 2 weeks ago, we showed off the beautiful 3D sample scenes and how smoothly they performed on mobile platforms. You may have already seen that, but there were also some other talks from our product managers that took place outside of the keynote. And I know many of you couldn't be there to watch that talk, and neither could I for that matter. So we brought the team here today to go over all those juicy URP details, and I'm going to be learning right alongside you. This is your chance to ask any graphics-related questions you may have, since we'll also be doing a Q&A at the end. The team who's coming on today prepared a lot of great topics on what's available for Unity now and a peek at what's coming in Unity 6. So without any more delay, I want to bring the team on. So let's cut to the URP sample scene trailer and then introduce our guests. And we're back. All right, I'm here with our amazing guests. I'm here with Jonas, Oliver, and Mathieu. Some of you have been here before. I think, Oliver, maybe this is your first time on the live stream, but for anybody who's watching, we'll have all of you do introductions. We'll start with Jonas to my right. Go ahead.
Yeah, all right. Hello, everyone. I am Jonas. I am a technical artist, and I work with the URP team. I've been at Unity for 4 years now, a bit more. And what I mainly do is just work with developers to make sure that our features work the way that they're supposed to, and also, we talk about priorities and stuff like that. And then for the past year, I've been mainly working on this new set of sample scenes that we've just released. So I'm super excited to give them to you guys and have you try them out. We've already gotten some great feedback, so it's very cool. I'm happy about the reception that it's gotten so far.
So happy to have you, Jonas. Thanks for joining us. And we'll go clockwise down to Mathieu. Go ahead.
Hey everyone. Hi. So I'm Mathieu. I'm product manager for graphics. I was product manager for HDRP. And now I'm product manager for URP as well. And I'm sharing the duty with Oliver, so that we both manage the two pipeline and the scriptable render pipelines. And I've been at Unity for almost 9 years now, more than 9 years. And I started as a solution engineer, so traveling around Europe and talking to many people, helping people on the ground. And since about 4 or 5 years, I help managing the strategy, technological strategy in different areas. So happy to be here.
Happy to have you, Mathieu. Thanks for joining us again. And last but not least, Oliver.
Yeah, hello everyone. I'm Oliver. I'm based in Germany, and I'm also a technical product manager on the graphics team, working alongside with Mathieu on our scriptable render pipelines, or SRPs in short, with URP and HDRP, because we want to also look at them as a cohesive platform. And I work with the engineers, with the designers, and with technical artists like Jonas here, so that we bring like all the requests from the community, like the asset store developers or game studios, so that we really help prioritizing what's necessary, what's good, how to make a better Unity. And I'm really happy to be here to present like the latest URP sample, and with this also like a sneak what's like the next versions coming. So Jonas will show us in editor like a lot of nice things. And I'm at Unity since 6 years nearly now, so I enjoy it a lot, and looking forward to this year.
So great to have you. As you mentioned, we're going to be looking at URP and like what we have today and what's coming up in Unity 6 will be, and this is going to be a very visual show. We'll be sharing screen in editor. We'll be looking at code, and we have some presentation slides prepared as well. But just maybe we can start with a bit of a high level. Start with URP and a URP overview. Just in general, what is URP? The Universal Render Pipeline. Matthew, maybe you can kick that off for us, and then we can talk about what we've been working on recently.
So maybe a bit of history here. We when I started at Unity, we were introducing Unity 5, and we were introducing the built-in render pipeline, which was the first PBR pipeline. And then we went through we went through some iterations on it, and after 4 or 5 years, everybody was using it almost. And now, 4 or 5 years later, we started to introduce a new scriptable render pipelines. The reason why was that we had like 3 main feedbacks. The first one was that the built-in render pipeline was a black box. Second one, that like our pipeline was neither really optimized for low end or for high end, and the third one was like as an artist, it was kind of hard to work with Unity because you need to assemble a lot of things by yourself. So this is when we came with this idea of like having scriptable render pipelines to open the black box, and then build on top of this the universal render pipeline, which was at the beginning the lightweight render pipeline, and which became the successor of the built-in render pipeline, but more like open through like we're sharing the source code, and optimized for mobile first, which would allow to reach the maximum number of platforms naturally, and then HDRP on the other side, optimized for high-end platforms and with a lot of tools for the artists off the shelf with materials, lighting, and so on, like advanced materials and lighting. So basically, that's URP story in a nutshell. So here we are, 22 LTS. It's been 4 years, I think, almost 5 years we introduced URP. So it's getting pretty good, close to parity with built-in and a lot of things. So one thing which was missing was like when you target that many platforms and when you can do this many genres of styles and games, like how do you really start like from there? What are the settings that you recommend and how do you set up your scene and so on? So we came with that idea that one sample would be really hard to cover everything. So we decided to go and do like multiple, like 4 scenes that would represent like different use cases. And at the same time, like when you have samples, maybe something I want to add is like when you in HDRP, we added a more advanced samples than what we had before, and it really it really put the quality of our product higher, because like at each version you have this reference scene where you have all these features working together, and at each version you can compare if it's going good or better or worst. You can add a feature on top of the other one and so on, and people can just use that.
Right. So these demos are like checkpoints even for the internal teams at Unity to kind of build upon the features.
Yeah, exactly. And it's a contract with users as well. It's like, hey, this is what you can do, and here it is. It's not like, oh, you could do all this stuff, but we have no proof point of that.
Right. Like you will be able to open this up, explore it yourself. So that's the proof. Great.
For example, like we said Unity, you can build on that many numbers of platforms. But here with these 4 scenes in URP, for example, you can really you can open and build it on your iPhone, on your Android, on your Quest, on your PC, on your Switch, and so on. And these have been tested this way, and this is our reference for us.
Yeah, and so the scenes we're going to look at today, they all run on mobile platforms, right?
Yes.
Yeah, and they all look amazing. So I'm excited to jump right into those. Do we want to jump into those right now, Jonas, and share the screen?
Yeah, we can.
Do a quick look at
do a little tour of them.
Yeah.
Do a little tour of the scenes. All right, awesome. And we can keep talking as we walk through the scenes. So let's open that up for anybody who hasn't yet seen.
I mean, one thing we shared them in September already.
Mm-hmm.
We had a kind of early access on the forum. So if there are people who are following the stream today, thank you a lot for all the feedback. We internally tested it during the summer and a bit before. And then in September, when we released it to everyone, we saw all these great comments, looking at everything and saying, oh, you missed this optimization here, and oh, you could add this. And so it was great to see.
Mm-hmm. Yeah, definitely.
And it was just available on GitHub now since a week, 2 weeks since Unite. You can directly have it from the hub, so it's very easy to get.
Oh, perfect.
Yeah. So it's just when you create a new project. For now, it's only available on 22.3. But if you create a new project in 22.3, you'll basically see it down here as the 3D sample scene URP, and you can see on the thumbnail that it's this project here. This version I have open here though is in 23.3, so this is what will eventually be the Unity 6 version, so we can show some of the newer stuff.
Perfect. And in the chat, we'll drop a link to the URP sample scene page as well, so you can get an overview of everything we're going to look at today.
Nice.
Yeah. And be careful to use the latest version of 22, because we had a few issues, I think 1 or 2 versions ago, where the sample was not loading well. So, if you check, be sure you'll download the latest version of Unity.
Mm-hmm. Yeah, and so as was said, we have 4 scenes, and this is one of them, the terminal, and this is the place that's going to be loaded up when you start the project. And that's because we decided we wanted more scenes than one. We also had needed some way to traverse them, and that's basically what this is. It's both a space to do, you can drop in your assets and check that they looked at their way that they're supposed to look in URP, but you can then also move around each of the different scenes, and then there's one room for each, and we built a nice transition effect inside these rooms where you can see
this
that
is really cool.
The screens will turn on. Yeah, and I can then place my crosshair on this hologram in the middle, and it'll start dissolving this entire room. Wow. And if I look away, it'll cancel it. But if I stay on there, it's gonna eventually reappear as this new location, kind of like a seamless transition.
Completely smooth. I love that.
Yeah, we're happy about it as well.
Yeah.
It was kind of an opportunity to show how to do. It's actually a custom post-processing effect that's doing the actual fading, and it's doing some nice tricks with using the stencil buffer to mask out, so it doesn't happen on the content that's consistent between the 2 shots, right? Because if I go back in here, you can see all that's on this screen is going to be consistent between the 2 cameras. Because if I'm here, it'll be on screen, and if I'm there, it's going to be the world, right? So we can basically make the transition when everything else is black. So I'll just go back here so we can see it.
It's not just an image; it's really a real camera looking through the second world.
Right. Yeah, exactly. It's rendering twice, so it is a bit expensive. It's not a cheap effect, and
it's just for a moment, right? Where there's 2 cameras rendering, right?
Yeah. So it's while you're here. It's 2 cameras, so to get proper parallaxing, you basically need this. You could probably do a trick where you do a cube map or something that's parallax mapped, but that's that's for a future thing we can do for low end platforms. But for now, this
and we have lots of questions coming in from the chat, and please, I encourage you to keep asking questions. I'll ask them throughout, and we'll also do a Q&A at the end. And so we have a question from Light Fight 42 asking, will it be possible to use the stencil buffer in shader graph in Unity 6?
So that's not a feature that we're planning to have. So what you can do is I actually thought that there were stencil settings on shader graph.
I think there is. I think there is, right?
Let's check it out. Let's see. Let's find the shader. Let's see here. Maybe we go to the Oasis and we can find
Asking us the good questions right off the bat. I like
yeah,
it.
yeah.
The chat knows what's up.
Yeah, maybe while Jonas loading, what's also nice about the transition effect we chatted earlier is like that is not only loading like the scene and the content in the background, but it's at URP even switching the renderer. Like when he translated or transformed into the Japanese garden, we were using the Forward Plus renderer, like the new one that we added to 2022.
Okay.
And this is basically like a different renderer that allows to have like more real-time lights on it. And when you then go back to the terminal, it's loading the standard renderer of URP there. So it's like basically also like the seamless transition of different rendering algorithms that you can use in your games depending on the scenes, on your content. So that's also, I think, worth mentioning here.
Amazing. So you have more control basically this time around. Great.
Yeah, so the shader graph itself doesn't have any stencil settings, and now I'm looking at the materials. No, so yeah, it's not something that we have. I guess what we do have is this render objects where you can override the stencil setting, but that's definitely something that we're missing. I'm gonna have to check with the team if it's something we can do in like a short amount of time. It shouldn't be too complicated, but yeah, I'll have to check that out.
Keep these and that's great. That's why we do this, right? We get questions that maybe we didn't think about from the community and take that as feedback. So I really appreciate that question.
But
we're
using
always listening.
But you're using the stencil, right, Jonas? On
So what I'm doing is using it to basically filter the rendering logic, but this is all set up in the renderer. So if I go in here and pick my renderer, you can see that I have this full screen mask. And this is overriding the stencil value. And this is then what I'm comparing when rendering everything else. So I'm basically using this to render this stencil effect. And then the actual, I think maybe that's... let's see here. So I think also this will do some stenciling. It doesn't look like it. Yeah. I can't remember exactly how the stencil is set up here, but at least the renderer is doing the actual stenciling, and then the comparison. It must be.
It's in the shader graph.
It's in here. Here it's available. Yeah. Okay. So it's only available in the full screen target. That's what it is. Which is there's actually no reason that it should only be available here. But yeah, if you're doing the full screen target, which the dissolve effect is a full screen effect. Nice. Then you'll have the stencil override settings down here. So that's what's happening. So the render
I guess that's something
pass,
you'll bring to the team, I guess, after this.
Yeah. I don't see a reason why this should only be available on the full screen pass. It should be on any target.
Perfect. Go ahead, man.
Now, full screen is a new stuff also, so maybe not everybody knows. Like it's a possibility to do full screen effects directly with shader graph. Mm-hmm. So it's this new node. Like basically, you can almost do everything with using shader graph. No, not everything, but like a lot more. Thanks to this master node.
In the Oasis, we also use it to do this fog, and that's actually something that I was thinking we could go through and try to kind of build from scratch to see how you work with these, like with the full screen shader graph, but also how to work with image effects and post processing in URP in general.
Should we walk through the Oasis for a bit just to give people a little look around?
Sure. Yeah.
And so everything is like in these scenes look really beautiful. Does it look exactly like this when you take it to mobile platforms, or are there certain adjustments made? How does that work?
Yeah, so no, it's this is on the PC high setting. We have a couple of quality settings in here, which I can't change while we're running, but you'll see that we have 2 for mobile and 2 for PC.
Okay.
And it'll look different, of course. The mobile high is still pretty good. The post processing is different. Yeah. Oh, this doesn't look right. So I think the post processing volume might be wrong for this. So this as I said is our branch that's gonna be up. It's gonna be the Unity 6 branch. So it has some things that are not working. But imagine that this was pretty.
Yeah, we'll do that.
And then so I guess it makes more sense to compare these. So it is a bit different, right? You can see that the shadows disappear. We're now on the low setting, and the PC low. It's for very low, like not very powerful PCs. Mm-hmm. We don't do the the additional light shadows or like this shadows at all. So you can see here we have a real-time shadow on high. If we go to low, it'll be much less defined. That's because this is a shadow mask. I can quickly show using, like if I go in here, there should be a debug view here that's where I can show the shadow mask. So this rendered shadow texture here, that's like a, we're using this for shadows on low end, but only, and then on high end we only use it for the distance shadows.
Got it.
Yeah.
Yeah, and this scene is basically recommended for like iPhone 8 or up, or like typically handheld consoles that you find on the market, like Nintendo Switch. You can run it quite well, like with good frame rates.
Yeah, it's a higher quality of all. We wanted to, like, this is the one where we're pushing a bit high the settings.
Okay.
Yeah, exactly. And currently it doesn't have VFX, but we have another branch where we're gonna add a lot of VFX, like sand blowing in the wind, and adding some more animation to the actual terrain material as well. That'll make it a bit more dynamic and alive. So that'll push the requirement a bit more. But it's a good way to show that we also can do that, right? And it's not saying that it's gonna be too high for mobile. It's still gonna run very well, 60 FPS on like an iPhone 13 or something like that.
And I have it running on my iPad Air here, but I'm not sure if it's like, it's probably not with the bright. It's like a little dark, but it's really like nice and fluid, like on the device directly.
Can you show it, Olivier?
Show it one more time. We full screened you so you could show it all.
Yeah, but it's really bright.
Let me see you walking around. It's live. It's live. Put it at an angle a bit.
Yeah. Bring it closer to the camera. Let's see.
Yeah, I don't think.
There's no
one thing. Like,
no. It's okay. We trust you.
We trust you. We trust that it's running on that.
I mean, if you look at the keynotes from Unite, like Steven, who was showcasing the samples, he was running them live, so you can see the image of how it looks.
And we'll drop a link to the keynote in the chat right now as well.
Yeah, and the garden scene is, I guess, optimized like for like as a reference device, iPhone 6s. So it's like a 8-year-old phone, maybe. So we often use like iOS devices to have like a reference point, so that people can compare it and say like, okay, that's like the suggested phone we use here, and with all the real-time lights, it's really running well on this device. And of course, like you can also lower the content that you might have to even reach like lower end devices. So, but this is like a reference content we wanted to show, because we also wanted to show like really like a modern game style that you could reach with URP, and not just something that was already possible like with all the other rendering before.
Yeah. And for today, a lot of our focus is going to be on post-processing script templates and the render graph. But if you want to see all the details that went into these sample scenes, we have a GDC talk from this year, and we also have the previous live stream, which was the LTS release live stream, where we dove really deeply into all of the features like forward plus rendering, the LOD crossfade, and all kinds of other features. But I think today the focus will be more again on render graph and the post-processing script templates, and a peek at Unity 6 as well, or we'll discuss some of the features for that. So maybe we can jump to that.
I mean, you like, for example, the dissolve effect that we showed at the beginning. You can watch it on the GDC talk. The presenter is really amazing. It's Jonas here, it's really cool. He did a really good job at like a very good live demo, also showcasing a lot of the things that we've shown now.
We'll make a better one today.
Yeah, exactly.
More ambitious today, so it'll probably fail.
And there is a Unite talk as well. Also, we did a talk together at Unite, detailing even more features on that will be coming soon.
Yeah.
So this one is exclusive. Is exclusive demos for you. Yeah.
Perfect. Love that. Love getting exclusive stuff on the live streams.
So Unity 6?
Yes, let's jump right into it.
So maybe I continue my story.
Please.
So it's funny because I've been telling this to some people for some time, explaining that 5 years ago, when we stopped, we stopped kind of investing more on built-in and investing on SRPs, that it was a kind of Unity 6 that we were starting, but on top of Unity 5, right? Because we introduced a package manager, so we thought, hey, we can actually add like a new renderers and all this stuff on top of Unity 5. So it's funny because I've been saying, and now like 22 LTS and basically 23 LTS is a kind of like a wrapping up of that cycle where we wanted all the things that we've developed for the past 4 or 5 years. We wanted them to work well, to be like super production ready and working well together. So that's why I think maybe that's why we call it Unity 6 now. We could have called it Unity 6 5 years ago, but it's a Unity 6 where it's actually, it has shipped games, you know, like URP. We see now almost every studios that we talk to are using URP or HDRP to build games since 1 or 2 years. And most of the games that we're seeing released today also are using SRPs. So it's funny, you call it when it's done, you know, somehow. Some people were saying, hey, Unity 5 became real, you know, like maybe in 2018, you know, and it's the same. I think what we've done is becoming really real, like in 22 LTS and Unity 6. So
and it's also to have like really like an easier naming schema in the end, like because it's like sometimes weird, like when you have like a version like now 2022.2, it's like first it's like not hard to tell, but we are like end of 23 now and it's the recommended version, so we thought like it's easier to get away from the yearly naming schema and really have more like this Unity 6 release, and I think it's much clearer, while it's still like a very production ready tooling already with the first name of Unity 6, because as Mathieu said, it's validated by like hundreds or thousands of games that have like reached millions of players or billions of players even. So like it's really like really like the render pipeline that the majority of studios uses these days for like really large productions.
Yeah. And so in Unity 6 we have a few features. We spend a lot of time polishing and also being sure that the core is right. But some of the, I would say, quality of life features also that we added. So for example, the codeless shader globals, you know, like we wanted also as much as possible that tech artists don't need to add too much boilerplates for nothing. So for example, in 22 LTS on our samples that we have a global fog that Jonas will also redo now in front of us, but like you have these global settings basically that you want to share, and before you had to write some boilerplate code for that. Now you have a dashboard for it, or if you have a win system, for example, that is managed through the shader graph, you can use that. We have also like it's small things. It's actually like a passion project from one of our QAs in the team who really wanted to work on that for some time. Like it's URP screen space lens flares. Maybe Jonas, you can play JJ Abrams live.
Yeah. Well, let's do some.
We were actually looking at this right before going live.
Yeah.
So in 21, I think, or 22, I forgot. We added SRP lens flares. So it's a lens flare that you add to a given light. You know, you take your directional light, and then you choose which elements of the lens you will display. So it really looks like the way you would do it in films with After Effects and so on. You have a lot of artistic control, but then you need to place it on each light, and then it only works on lights. It doesn't work on specular highlights. So this one is like very automatic. We can see it here. You just add screen space lens flares.
Oh yeah, it's on the post-processing menu, and you just add it and just boost the intensity, get it up there. And there's also streaks if you want to go like full sci-fi. Let's go like this, and then I can just put them out here.
Yeah,
as you said, Matthew, J.J. Abrams would be proud of us right now.
So like, look at this.
And it's nice because it works on emissive. It works on specular highlights. I don't know if we see it on the reflections on the water, but like you would also get the highlights. So if you have a racing game, for example, it's perfect to have the lens flares on the car. Yeah, see it here on the water. It's pretty cool.
Cool.
Yeah. So it's great, you know, like it's very easy to add, and it's a nice thing. It's kind of combination of Bloom and lens flares.
Yeah.
It's a little gift, you know, and it's great when you have people motivated to learn something.
You have to be careful with it though, because it can get pretty expensive. It's kind of like a feature that I would reserve for the higher end, because it uses the bloom buffer, but it has to do additional steps, right? It has to resample the bloom buffer a lot of time, and especially if you're doing streaks, it has to do a lot of passes to draw out the buffer like this. So just be a bit careful with it, and remember to profile.
Yeah, it's also great. You can use it in like cutscenes or for moments like that. Basically, it doesn't always have to be on at all times. Yeah.
Yeah, and they are like it's kind of the same price of the bloom right now, like altogether. I think a bit like not too far away, and there are ways to reduce the cost a bit somehow with the samples, and if you don't go too crazy with the effect as well.
So it's on top of a bloom, right? So it's running bloom, and then you run the lens flare on top of it. So it's basically taking the bloom buffer and doing extra work on it to give this flare stuff.
Exactly.
Nice.
And then we also like something we've been working on as well, like for a long time. It's the next slide, I think. Is like we have a team which really works on also unifying the pipelines and aligning the workflows down the line. So for example, you know, in HDRP we had global volumes, so that when you open your project, basically you can have stuff set up by default, you know, so that it's everywhere on every scenes. You would have the bloom or not, or the different effects already set up for you. And and this is now also like this is exactly the same now for URP and HDRP. You have the same system. We could see it in the editor or not, but and the good thing is too that you for each quality level, then you can choose a volume that would override these global settings, so that after for each quality settings you can override, for example, you could just like enable the screen space lens flare on the global settings, and then override it when it's too low to disable it by default, and then it will be automatically disabled. And if you want,
I'll just quickly show it. So here in the quality settings, we have the pipeline asset for PC high, and we can then at the bottom here, it'll have a volume profile assigned, right? And then I can do the screen space lens flare on this one only, and that will mean that here it's running, but if I go to PC low, it'll now not run the screen space lens flares.
Exactly.
Which is a really
and what's also
way.
Important here to notice that we improved the performance a lot on the volume framework, so that it's actually usable on like also lower end platforms, so that it makes more sense for URP on all the devices. On HDRP it was probably neglectable like on most platforms, but like the URP, that was really important and hindering like to use it full-fledged. And now with the new revisited volume framework, you can use it like here for the global volumes, for quality settings, but also to blend them in your scenes and so on. So that's really, really good.
Yeah, we really wanted like volume to be first citizen for SRPs and usable around there. Like that's very important to align also the workflows between HDRP and URP. Yeah, and we had some details. Sorry, maybe also like for example, just to note, we, for example, before you were placing a global volume on the global settings, but you could have a volume just setting bloom, for example, and then you had no idea what was the default value of the other post-processing. Now it's really listing all the post effects that are possible, so that you're sure to control exactly what are the default values. Because some people were like, I don't understand, it's very expensive. It's like, oh, you have this enabled, and they say, no, I don't have this enabled. And then you're like, oh, go to the global volumes. Oh, it's not enabled. Ah, yes, because there is this default value which is hidden, and you should add this value, you know? So now it's very clear this way. Yeah, little improvements.
Quality of life, kind of accessibility improvements. Great. We have a question that's coming in from the chat.
The other feature that we're adding is this new template for post-processing, right?
Jonas, I think Hassan.
Sorry, we just had one question from the chat. I don't know if Jonas can hear me, actually. There might be a... Oh.
Jonas, can you hear Hassan?
Yeah. I can't hear Hassan.
Oh.
That's why.
We'll get that fixed. But yeah, we have a question from the chat asking just in general, this comes up quite often. I think it'd be good to address it. A lot of people ask about the render pipelines, and if there are plans of unifying render pipelines at all, how that will work, URP, HDRP, how we're approaching this at the moment.
So yeah, so as I mentioned, we started already 2-3 years ago to work on like aligning more the pipelines. So we really worked on all the graphic settings and on the way we are setting up the pipelines together. And our initial goal was to align the workflows and to be able to have 2 pipelines in the same project. So for example, now you can actually put a universal render pipeline asset on a quality setting and an HDRP one on another one. Like you can actually have the 2 pipelines in the same project. It's possible, but it's not really like I would say supported. That's the direction we want to go. So you can test by yourself. But yeah, it's where we want to go, basically, to be able to have the 2 pipelines coexisting with better alignment on the workflows. This is the direction we're going to. But for
we already have like a lot of teams working like on both pipelines, like both, of course, like the shader graph, VFX graph, they work with both. You can have like the targets there, but also on the foundational things, it's really like a shared engineering team, a shared product resources, Q&A, so that we really like converge the 2 over time. It's of course nothing that we can do like from one minor version to the other. So it's really like, but it's like a goal for us to have like the scalability much easier, but still keep the benefits of the 2 pipelines, like with HDRP really reaching like a full physical based rendering with high-end visuals on like the modern consoles or like overall PC and console, but keep like the really the extensibility, customizability of URP to really create unique lighting, unique styles for your game. So it's like 2 philosophies. We also have 2 like different target devices. Like a mobile phone is really different from the architecture, the GPU, than like a tethered device that consumes like a lot of heat, a lot of energy. But it's definitely that we want to have alignment more on the workflows, on the extension points and everything, but still keep like the uniqueness of both pipelines intact. So I think that's really important.
And so
we are also careful there.
Yeah, that brings up 2 other questions. One about unified shaders for both URP and HDRP. People are wondering if there's going to be such a thing as a unified shader for both, so they don't have to convert URP assets to HDRP assets and vice versa.
I mean, you can do it already today. Like if you're doing a shader graph shader, you can select both URP and HDRP as targets. So it's already possible. And that's basically, that was our baseline. Like internally, we've done some tests where we have a project and which is like which has the 2 pipelines on the same project, and we have only shader graph shaders, and then you can swap from one pipeline to another one. So it's possible. What we're missing is to have a standard one, to define a standard one, which would be the default one and works for both shaders. That's something we are considering very strongly for the future.
Oh, great.
But yeah, we really wanted to go faster on this, but down the line we're realizing also that a lot of people end up using also naturally just one pipeline in production, and so like the coexistence was a bit less important than actually polishing and finishing some of the features of URP and HDRP. So we spent our resources on this more for now, but that's definitely on the top of the stack for the future.
Okay, great. And earlier you mentioned having both some URP features, some HDRP features in the same project, some HDRP lighting, for example, and some things done differently in URP. Is it the case that if you want to build, let's say for the Switch or for a more lightweight platform, you can just turn off the HDRP feature, so to speak, and then have a different looking version that's built for the lightweight platforms, and then when you want to build for a Sony platform or a Microsoft platform, you can just turn the HDRP features on? Is that kind of the goal, the vision?
I mean, probably down the line, we want to align the artist workflows. That's the first thing. But then the real question is, what do you redo? If you go from low to high, where do you spend your energy redoing so that it looks better? Right. And sometimes you will redo the lighting, because you won't be able to bake. Like you will want more real-time lights. You will want to tweak the quality of shadows. You will want to balance between what is baked lighting and indirect lighting and so on. So you might redo the lighting, but still we really want to, the vision is to have more aligned workflows so that you don't have to place twice the lights, for example.
Yeah.
But down the line very often, and you could potentially do it already in 22 LTS, is if you have a lighting scene, for example, with your post processes and your lighting, and you have a URP one, and then you if you want to move to HDRP or vice versa, then you create like an HDRP lighting scenes. Then you keep like the set sharing the same shaders with shader graph and all the placement. Then you could swap the scene, and then you would have a lighting made with one pipeline and the lighting made with the other one. Yeah.
Okay.
Yeah, but as Mathieu mentioned earlier, it's not really like the supported or a use case that we would advise right now. It's like you could use it for porting your game. So if you like start on like PC and consoles with HDRP, but would like to you realize you also want to target like a lower end platform, it's possible to use like the coexistence to port it easier, but it should not be the default case right now that you use both pipelines for one title. On the same time, there are titles that did this, like Lego Builder's Journey, for example, uses HDRP with ray tracing and a lot of features on PC and console, while on iPad and so on, they use URP.
On Switch.
But again, on Switch as well. So, but again, like it's also like oftentimes like more like a choice of art style. URP is also leveraged like a lot on PC games in the end, where they really want to extend it or override the light loop, where HDRP is right now, because of its physically correct rendering everywhere, it's less a little boxed more. So I think that's also important to understand that URP is not only for mobile right now. It's more for like a genre type or like a.
And I've interviewed many creators on the creator spotlights that we do here on the live streams who have building games for PC using URP, and the games look absolutely stunning.
Exactly.
Just one example, Lost and Random is a game that they actually started in HDRP, but then decided, hey, we can make this look just as good in URP using just a few different tricks here and there.
Yeah.
And the game looks absolutely stunning. You should definitely check that out. And the creator spotlight is available still on our YouTube. Yeah.
Yeah. I mean, we will share more, I hope, like next year on the vision and so on for the future. But yeah,
that's great to hear.
It's top on our mind, definitely. It's one of the super exciting stuff after Unity 6. Yeah, definitely.
Amazing. So basically, the vision and philosophy going forward is aligned workflows at the very least, and we go from there.
Yeah.
And people in the chat, by the way, are very excited about any quality of life improvements. They're mentioning they're like +1 for any quality of life improvements. So
yeah, that's right. Also keep them coming. Like really, like sometimes it's the small suggestion that we might overlook. Like I mean, we are of course like aware of like some shortcomings and work with UX to improve it. Sometimes it takes like longer than we all wish, of course, but like keep like recommendations. So we try to do our best to get like really less clicks as possible to achieve the things you can do.
Right. That makes a lot of sense. So we'll continue with the presentation.
Yeah.
Maybe we can bring the slides back, and Matthew, you can keep walking us through it.
Yeah, I mean, I will let the mic to Jonas, because he will show us how you can now do custom post-processing effects, like as a tech artist, Unity 6. So yeah,
great.
To you.
All right, Jonas.
Oh, we cannot hear.
Can we?
I'm
not sure if.
Okay.
Oh, there we go.
Okay, so yeah, there we go. What we added is a new template, a new script template for post-processing effects, and I thought I'd just show it off in the editor.
Yeah, please.
So I'm gonna open up the Oasis scene here, where we have this fog in the background here that is a bit more complex. It plays a bit more with the light than the built-in fog in URP. So what I'll just do first is I'll just disable this one so we can actually replace it. And let me just create a folder for it here. So what we added is a new item in the create menu under rendering called a URP post-processing effect, and it says in parentheses render a feature with volume, and that's basically what it is. So when you create this, you get two scripts. One is the render a feature, which is like this thing that was part of URP for the longest time. It's basically an easy way to inject passes into the pipeline, and then you have the volume component, which is then setting up all the data that's tweaked through the volume system. And already out of the box, this actually does something. So I'll just add it. I go to the renderer here, and then I'll just add it at the bottom. We now have this height fog renderer feature, and I'll just add it, and we'll see that everything is inverted and doesn't look like a fog at all. But at least it's doing something. And this is just our like out of the box image effect that we just added so you can validate that everything is working. And what's great about it is that it of course also comes with the volume. So this is the existing fog volume that I'm just going to disable, and now in post-processing custom we have the height fog here, and I can add it, and it just has a single property which is going to be the intensity, and that's working. So the pass that's injected via the renderer feature now listens to this property that's controlled via the volume system, and you can build your custom post like that.
Yeah, and that's a good example of a quality of life. So it was probably possible before, like with like a lot of boilerplate code, or where you need to know where to click and so on. And now it's like a menu item that is generating like a very basic effect for you, and you can start from there and inject your code. So it's much easier, and hopefully brings us a lot of extensions for our users so that they easier can customize URP.
Exactly. And now I'll just create a material or like a shader that we can then replace. So we don't want to run this in inversion effect. We want to run our own stuff. And this is where we create the full screen shader graph that was also discussed before. Let's call it like this. Now I'm just going to create a material as well that uses it.
Yeah, and we discussed this before as the fog that, or the haze that's in the desert sample scene, right? They're using this full screen node.
Exactly. And now we're going to do the same. And this target is very simple. It just has a color and an alpha. And we'll make sure to set the blending mode to alpha so we can control it through this and just give it an orange color for now. So
nice. What
we want is to basically see this orange color everywhere. And that's a sign that we're actually running our shader instead of running this inversion shader. So I'll just copy the path to this material here and open up the renderer feature. And yeah, so this is the automatically generated code, and it is quite a complex file. It has a lot of lines. You can see there's like 300 lines of code. Okay. But that's because we wanted to cover the most general cases that you want to do with post-processing. So what it's set up to now is to basically copy the screen content to a texture and then sample that in the inversion shader. So you can kind of so which is a very common thing to do, right? You wanna know what's on screen already, so you can modify it if you want to do tone mapping or for any other effect. But we have these nice regions in here, so it's easy to modify. And what we want to modify is this material field here, which is one of the feature fields, and it's assigned down here in the create method. You can see that there's the material here, and it's just loading up the asset from this path. And what I did was just copy the path to my material instead. So I'll just paste that in here, and that should then mean that we're seeing the orange color. That's just the solid color that was assigned in the. Oh, we don't, because of the serialized property. Yeah, so this is checking if it's null, and it's not null because it was already assigned to the inversion material. So let me just assign it out here. And it compiles. Yeah, so this is the color and the fog, and it's very pretty.
And it's done.
And it's done. This is the fog.
Very foggy.
Pretty foggy, yeah.
Beautiful.
Like a lot of dust in
it's
the air.
very dense.
You just jumped into a pool of orange juice.
Yeah, exactly. Now I'm gonna enable the frame debugger here.
Yeah.
So we can see what's actually going on, and we can see that we're actually injecting two passes down here. The height fog renderer feature is injecting two passes, and that's what I talked about. Where first it's injecting a pass that's just this custom post pass color copy. So it's just copying the content to an off-screen texture to use for later, but we actually don't need that for this effect because we're just gonna alpha blend this fog on top of what's already there. We don't need to sample it in order to modify the value somehow. So we want to turn this off because now we're just wasting resources doing this copy. And that's what I said, where we wanted this to be to basically cover a lot of stuff up front, but also be able to modify it. So we have this copy active color, and we don't need this, so it's just a matter of I'll just set this to false. And now when I go back here, I won't see any changes, but I'll not be doing this extra like unneeded pass down here, and we just have the single pass that's doing the fog on top of everything. So that's really nice. Now, the thing that my pass currently not is doing is it's not considering this intensity. So let's change this. And yeah, so I'll jump into the volume component here. And this is where the intensity property is defined. And now I'm just gonna replace this with like a density property instead and call it density. And this is gonna be the density of the depth contribution of this fog. And this is just, regular volume stuff. There's nothing about this that's URP necessarily. And then in the actual render feature is where everything is hooked up. So if I go into this shared rendering code section, we'll see that there's a custom volume component section. And this is where the volume is fetched, the volume component is fetched. And we're then setting shader properties from here. So I'm just gonna set this depth density instead of setting the intensity. And then of course, get it from here. And now I can declare a property inside my shader and then use that in my shader. So up here, I'll just declare this depth density property. And you can see here that
to the shader.
Yeah, exactly. And this reference is what I basically have here, setting the float. And just as a test, I can just put this inside the alpha here. And now we should see this blending with the density value.
Oh, there we go.
So that's how to set that up. But of course, we don't just want it to be uniform. We want this to be based on depth. So I'll just add a scene depth node and set it to I mode. And I mode basically means that this value that comes out here is going to be equal to the distance from the camera to that specific pixel or fragment.
Got it.
In world space. And I could just do, I guess the most dirty way to do it is to just multiply the density on top of this distance. I'll probably need to saturate it because it'll go really high. Saturate just clamps it between 0 and 1. And now if I bring my density down, we'll see something that looks kind of like a fog.
Nice.
It's not pretty yet. And I don't really like the fall off. We can see that it falls off like slowly and then gets like a critical point where all of a sudden it moves really fast.
Right.
So I'm gonna do something else, which is like an exponential fall off here. So what I want to do, and this is some math that's a bit hard to explain, but it's basically we're gonna use this exponential node with the two base. This is equivalent of doing like 2 to the x, so like 2 to the input is gonna be what's coming out here, and then in order for this to work, we need to actually do the negative input. And then we also need to invert it in the end. And yeah, I was thinking about showing this on like a graph plotter, but I think for sake of time, I'm just gonna do it and hopefully it works. And then here we have a much nicer fall off. And
oh yeah,
at different densities,
right
like
away.
It's much softer and it's much closer to how particles like this work in real life.
Yeah.
Now that was the depth component. I do want to add an offset to this as well, so we can basically determine a distance where the fog will, like, within this distance there's not going to be any fog, and then it just starts a bit later in the distance. So I'm just gonna subtract this depth offset here to just move my distance range away, and then I'll just make sure that it's positive. All right, let's see. And of course this value is means nothing right now. We need to hook this up to our volume component and to our with our render feature as well. So I'm just gonna copy this. It's just gonna be a regular float, doesn't need to be clamped. And this will be the depth offset.
And that's what we see here is also typical Unity, right? So that you can program here in C#, go back to the editor, it compiles super fast, and you get basically, you can extend the editor, how it behaves. You create your own volume and iterate over it all in C# here to really extend Unity to your needs. I think that's also important.
Yeah, totally.
And for everybody watching, if you have any questions about what we're
I
touching
think
upon, go
you
ahead
missed
and
an
ask.
H
I did?
on the first one.
On the volume?
On the
So we
component.
have it
Yeah.
here.
Yeah, depth offset. Yeah.
Oh,
Okay.
beautiful.
Yeah. Luckily, my IDE fixed my typo. Did everything compile now? It didn't.
If only everyone had that Matthew while they were coding to catch the. You'd have been
didn't-
looking for that H for hours.
But
I didn't
It's-
catch the error. So.
oh, I didn't save this file. Sorry about that. So now we have the offset, and if I go, so now I have another property here, right? And I can just push the fog back. And something I like to do when working with stuff like this is actually to just put this straight into the color and just keep the alpha to 1 to get kind of like a debug view of what my fog is gonna look like. And I think this looks pretty good. I probably want to do a way lower density here. So we got, I like how this like frames it with the foreground not having any fog, and then we gradually move into the background until this hill down here has a lot of fog.
Yeah, feels like there are a lot of layers to it now.
Yeah, exactly.
Yeah.
And I want to add a height component as well. So right now, this dune is completely in fog, and I'll just I'd like this here to be more foggy than this up here, and
yeah,
and so that's just a matter of adding. We're gonna do the properties again. This will now be for the height.
So we added depth, but now we want to add some height.
Yeah, we want to add like a fall off from height, so it's more dense as it gets closer to the ground, basically.
Yeah.
Height. Oh my god. And this is of course the height offset and the height density. Oh, did I not? Yeah, there it is. So that should be the C# part done. And then for the actual fog, I'll just add the properties. Boom, boom. Height, density, and height. Wow. Height offset. And yeah, this then works pretty much the same, but of course, instead of using depth, we're now going to be using the actual Y position of the fragment. And this is where the full screen graph is really awesome as well, because what this is actually doing is it's just rendering like a triangle that fills up the entire screen, and that's basically the effect, right? And what the position node usually gives you is the interpolated position of the vertices, but it doesn't make sense to have the position of the vertices because they're just like really close to the camera and pushed away. But what the full screen target will do for you is it'll actually provide the position of the fragment instead of the position of the vertex that it's interpolating. So that's really useful. It might sound trivial, but it makes your life a lot easier. So otherwise you would have to recreate this from depth, but this is actually already done for you.
Oh, nice.
And I can just get the Y component here and start working with it. We'll subtract the offset like this. And now this is gonna work a bit different because this gets more dense as we go high, but what I want it to be is dense, at the bottom here. So to do that, I'm just basically not gonna do the inversion at the end here, but that also means that I have to invert my density. So as I multiply the density, that's gonna be inverted. Then we still negate it and put it in the exponential. But then we don't do the 1 minus here. So hopefully this works. And if I look here, it's very white. But if we go down here, it's because the density is very high. So I can bring this density down, and you will see that now we have this fog that has like it's 1 meter high in the air, and we can move it up and down using this offset here. And I'll put it like here at 5. Then we can kind of tweak this until we see, like, I want this nice fall off here on this dune where it's like the top is kind of dark, but the bottom is white. And then we can just multiply these together to get, you know, the aggregated effect like this. And this is going to be the mask for the fog, or the alpha for it.
Just keeps looking better and better.
Yes. Hopefully we'll get there, because now we're going to move on to the color, because the color is not amazing. It's just this very dull orange one, right?
Yeah.
So the first thing I'll do is I'll just add a color to the actual properties here. Instead of just hard coding this to orange, we'll add it. And same as before, we go into the volume. We make a new color parameter and give it a default. I'm just gonna do yellow because that's fast. And then we read this and assign the property inside the render feature. So set color. This is going to be the color property. Right. And what I'll do already here is I actually want this to be an HDR color, and that's what's really cool about doing your own font like this. That you can kind of use some more advanced graphics features and colors. So I'll just make sure that this picker here, the color picker for the volume, is gonna be in HDR, which is gonna give us a lot of brightness.
And can you explain to people what the HDR colors are?
Yeah, so by default, or like if you don't have HDR, it means that you can only represent a very limited band of colors. You basically have brightness 0 and you have brightness 1, and you're not able to represent everything that goes beyond that.
Yeah.
But if you have HDR, that's going to be a high dynamic range, and they're kind of it's used in 2 different contexts. One is an HDR monitor, which means that, okay, I have a monitor that can both understand complex color data and also display it. But you can also just have HDR. HDR is also useful even if you don't have an HDR display, because if you have like this very precise color buffer for your screen, you can then tone map it. That's what makes bloom really nice, and colors in general work well on these pipelines.
Like if you don't use HDR, you get saturated things a lot. You get like things which are becoming all white because you couldn't get that precision to display, like to calculate it.
Yes,
exactly.
So you calculate it in a white color space, and then after you tone map it so that your result is just displayed in the end. And in an HDR display, you tone map it towards that new display, but with a wider color range.
Yeah, and what we'll see now is that we have the color, and it's an HDR color, so I can start increasing the brightness. But what we're seeing is not amazing, and that's actually a good example of what we were talking about, where HDR color buffers, even if you don't have an HDR display, is great because you can use tone mapping. But the problem here is that our height fog render feature here is basically running after the bloom. So the bloom is calculated, which adds all these nice, glowy effects. But then after that, we're doing the fog on top of it. So our fog is not getting bloomed. And that's of course a problem. So the fix for that is to go into the renderer feature.
We're changing the order.
Yeah, exactly. So we're gonna set in the beginning of the script here, in the feature methods, we have the add render passes function, and this is where we're setting up an event. And you can see that it's doing it after rendering post processing. But what we want to do instead is go before, and hopefully that will make this very, very bright fog like
Bloom.
interact better with the environment, right? So now we're actually getting nice glowy bits around here, and the color seems much more reasonable. And that's HDR at work, basically. Yeah, let me bring the color back. So I'm just gonna copy the color from the old fog, and it's not done yet, but we're very close because it's still very mute. It's not a lot of color that we're getting in here, and that's because we're missing the contribution from the sun.
Okay.
And that's the last thing that we're missing. So I'll just go in here and then add the main light. So this is a node that's not actually part of the regular shader graph library. As you saw, it was inside the subgraphs here, and it's one of the nodes that we created for the sample scene, and we use it in a lot of places. It's really useful. And creating a node like this is so simple. It's just, we just have the custom function here that's running a bit of HLSL script. It's just calling the URP get main light function. But then instead of having this custom function everywhere, we're just wrapping it in a subgraph, which basically, it's almost like your own little node library, right? Where I can have a node like this. And what we want to do with it is we want to dot it with the view direction. So what I have in mind is to add like a halo effect around the sun. So as if the sun is hitting a lot of particles in the air and then entering my eye. So I'll do a quick dot product here, which kind of like gives me the angle between the view direction and the sun. So this is almost like, you know, adding as if I was standing inside a big sphere. So we can see the sun is over here. Oh, that's weird. Okay, I don't know why that looks like that, but at least here you can see that we have this giant halo. So it's on the wrong side right now. Okay. Which I'll just invert the direction here.
Meanwhile, people in the chat are really loving this walkthrough so far, and for people who are wondering if there will be a recording of this, as soon as this is done, when we go offline, the recording will be up on YouTube right away, so you can go right back and watch it at your own pace and you follow along.
Yeah. I was worried it was gonna be too fast, but yeah, I guess if it's uploaded, it's
perfect.
It's great. It's perfect.
All right.
Yeah.
So the halo is here. The fall off is very sudden though. Like the color change from here, or intensity change from here is very harsh, and then there's like almost no change here. So we'll fix that quickly with just doing a quick power to this. So we'll just do a power, put in 8, and the reason this is pink is because of actually shouldn't. Oh yeah, let's saturate this product. So saturate, so we don't have any incorrect values going into the power. And now, we put the power to the 8, so now we have a much smoother fall off. Not a harsh transition. Before it was here and then it stopped here, but now we have a nice fall off. It's a bit small now though, so I'll just take this dot product and bring some of that value back by remapping it. So this is going from -1 to 1 right now. We're only using the part that's from 0 to 1. So now here what I'm doing is just remapping the part that's like, so some of the negative value get mapped back to 0. So we basically are considering more of this dot product than we were before. So that just increases the size of everything, but we still have the nice fall off.
Yeah, and as Jonas is tinkering around here, that's really what we want to achieve with URP, that it's so extensible that you can like really achieve the look that you want to create for your game. So that's really in HDRP, it's like the fog is like a really important component that is locked because it's calculating all the lighting to be physical correct. So that's really like a different philosophy we have here. And on URP, it's all about extensibility, like override, create your own fog in this example, to really like get like the style that you want to create here. And don't care if everything is physical correct. Maybe you like a different look or style. So I think that's really important to highlight as the difference between the pipelines.
Got it.
Yeah. And what I just did now was I just took the color coming out from the main light node and multiplied that onto this halo mask that we built, and that just gives it this. So it's that easy. And if you have the main light node, it's super useful for all kinds of things, getting color as well. And if it's not really relevant for this, but the node also has this shadow attenuation. So if you want to do something with shadows, you can do that as well. And now we just have to add the existing fog color.
While you do that, Oliver, I just wanted to follow up on what you mentioned. So with this being more suitable for like stylized looks for URP over HDRP, can you achieve similar things in HDRP as well? It's just a different process, or how would it work if you wanted to do something in HDRP but also stylized and custom?
Like you could use you have exactly the same like buffer access and depth, so you could actually copy paste that exact script here and put it into HDRP. Where it's getting more complicated, it's more like when you want to manage it in terms of like having the right intensity value so that they are physical, so that they reflect well in screen space reflections, in all the reflections, in the baking, for example, of lighting. It's really the combination of features that you get at some point, which is making it harder. But you have exactly the same access to the nodes. Like the full screen master node is is the same for all pipelines. You have access to the depths, to the color buffer, exactly the same.
Yeah, but at some point you break basically the promise of this physical based look, so that your materials work in any lighting condition. That's of course like as soon as you override something that is not plausible in reality, it might also look like your material might look totally off in a different scene. While if you don't break HDRP, like the logic, it would look correct everywhere. So that's where we then just have to be careful. But of course, as Mathieu mentioned, it's still Unity. It's like you have access to the data, so you can do that. But the combination of everything together is where it's getting then just a little where you need to be more careful, while URP is more easy to do it here.
Yeah,
makes total sense.
You build the style from the ground up in URP. You start from the basic rendering and then you add pieces on top of each other. In HDRP, you add all the things that you have in HDRP, and then you tweak your style from the top down somehow. You will
start
tweak this
with
style
the real world and then tweak basically.
Exactly.
Yeah.
It's like a real movie. You put you don't change the color of the light, you add a filter in front of the light.
And it really requires a prerequisite understanding of just how the real world lighting works, and that's of course it takes a bit of research, but at the same time it can be really handy. Like if let's say you're building a mansion and you want a very particular light bulb with a certain amount of lumens, you can literally replicate that that look in real time, which I think is very interesting.
But it's also a goal in the long run to also have more physical units in URP, so that at least what we discuss a lot internally. So it's not that we don't want to have this kind of real world units in URP, but it's also both pipelines have their meaning there. So it's really a different style that you can create with it.
Yeah,
makes sense.
Yeah,
and Jonas, you were about to show us the result, right? When you jump into the placing. So
maybe I said one thing before is actually the full screen pass here that you see, and if you are using HDRP, if you go on the package manager and you go on the HDRP package, there are samples in the sample tab, and you can see also samples of full screen pass like this to do raindrop effects on the camera or outlines. So again, what we're showing here is really kind of generic to the pipelines.
Yeah.
And same philosophy.
That's great.
Sorry, go on, Jonas.
Yeah. So this is pretty much done. So I guess where we left off, it was looking like this. I just multiplied the color, the color of the sun with this mask, and then I'm just adding in the color of the fog color that's defined in the volume. So now even if we look away, we have some color over here. The color is weird. It should be orange like this. I don't know why. And then just plugging in the alpha that we built in the beginning into the alpha, and that's pretty much the effect done. And everything is then controlled through this this volume here.
It's really cool.
Looks amazing. Can you just mess with the values while live?
Yes. So I guess so I can even turn it off, and we'll see the defaults, which are gonna be very ugly. And I guess this is a good way to talk about the default values that Mathieu mentioned as well, because now what I have is in my project settings, in the global settings,
Yeah.
I basically have settings here, and here you can see that my height fog is now showing up. And because the volume, this outdoor volume, is no longer overriding the height fog, it's now taking the properties from this default one in the global settings. And so here I can set the settings, right, and I can make sure that it has some values that make sense. We can do like
And it's
this,
important to change these default settings because as you create new scenes and you want to have new environments, you don't want to start every scene with a big glowing orange ball of fire.
Exactly.
So,
Yeah. You're exactly right.
And sometimes it's the opposite, right? You want every scenes to be the same, and you don't want people to add volumes to every single scenes.
Yeah.
That's the power of it, also.
That's right. That's right.
So now it's very hazy.
Nice.
It's really cool.
Yeah.
That's really nice.
Looks amazing.
And you can use a master node also, like this so the full screen master node. You can use also it on to make custom render textures also. If you want to do procedural textures, you can do this like a similar thing to generate textures that you will reuse in another shader, for example. Like it's super powerful. All the things you can do. In HDRP, you can also use it to create procedural fog, for example, if you and plug it into the fog material. So it's really opening huge possibilities for tech artists.
And here we use the eye node, so it's like from the camera, right? But we had some comments in the chat like, could this be used for creating, for example, a very popular genre, battle royale? You know that usually there's a ring of a circle that closes in on you, and usually there's like a smoke or a fog. Somebody had suggested that in the chat. Could this feature be used to create like a circle that's closing in on you?
Yeah, it could. The thing is that this will, like this position node that we have currently is gonna only, like, it's using the position. So if there's no geometry, like if in the sky, if you want to see the shield in the sky, you have to manage that explicitly because there's no geometry up here. Yeah. So the if you have like I can quickly do something probably. So if we just take the position node here, and we just do like a length, and then we just do a quick step here. So maybe like 5 units, and then we put that in the alpha, and keep the orange. So now that wasn't what I want. 5 units probably not enough. Let's do 25. Let's see. Nothing is working. Let's see here. Length in. This should of course be the position in view space.
Absolute.
No view space because I wanted to, so here I basically have this, right? So this is a circle that's now around the camera basically.
Right.
And you can do anything with this, and I guess if it was like a battle royale, I can no. So in a battle royale, this would, instead of using the view position, this would be a position you probably send to the shader, right?
Yes.
So instead, I would maybe like I would have a position property here that's updated through my render feature, and then I'll be like, okay, what's the difference between the like how far is this? Is there a distance node? Yes. So how far is it from the position of the current fragment to the position of this origin where my PUBG level or Battle Royale level is shrinking to?
Yes.
And use that instead of this link.
Perfect. So
Very nice.
that's a yes to everybody in the chat. You can use it for that purpose.
Yeah. No, go build a Battle Royale.
Go do it. Off with you.
It was a nice yes.
Yeah. Exactly. Great.
Okay. Yeah. I'm not gonna bother fixing this up. It works. We saw.
Yes, that was a great tutorial, and for anybody who wants to go back into some details, again, this is going to be available as soon as the live stream is done. This is going to be up on the YouTube. You can go back and check it out. I think then the next thing we want to talk about is the APVs. So I think we have some slides to show this off, and Matthew, you'll introduce us to APVs. So what are APVs?
Yeah, so APVs is adaptive prop volumes. It's a system like, so when you do when you do global illumination, which is really what's giving this kind of photorealistic look, because you have the indirect lighting, or even like for stylize, actually it's very useful as well. But like having all this light bouncing on the world, you know, if you have a red wall, an engine can usually only compute like the light on that wall, but not on the ground if it's white, because otherwise you have to send rays, you know, so that it bounces, so that the light going through the red wall is making the ground red, kind of. So to do this, you need to either bake or to send rays at real time. And sending rays at real time is very expensive, so usually you're baking this data. And to bake, you could use light maps, basically. So that will just store all this indirect lighting into these textures. But the problem with light maps is like you have to have special UVs like for the light maps, so that they can store them, so that the geometry can store this indirect lighting. It's also quite long to bake, because you're sending rays everywhere on every single part of the world. So then it doesn't light the dynamic objects, so you add light probes normally on top of it. And these light probes are kind of low quality. It's very low frequency. So it cannot really replace the light maps right now. It's just here to light the kind of dynamic objects if they are not too big, you know. And that was the status until, I would say, Unity 6. Now we're coming with APVs. So APVs is kind of light probes, but with a higher quality of rendering. So the good thing is like you can render larger objects, basically. So down the line, you could even imagine that you can light totally your world with APVs, or at least you will need a lot less light maps. So which means that it's faster to bake, you have less UVs to do, which is great. But the problem with the light probes that we had also was that you need to place them manually. So
Yes.
First, it's very long. And then two, if you change the world, then you need to remove them by hand, you know? And you need to change yourself, the density, you know, like I want to place more near the wall. So it's a lot of work, actually. For APVs, it's automatic placement. So basically, by default, you just place a probe volume, and you can say, like, give it in the entire scene, and it will just place all these probe volumes for you. And it's not just automatic, but it's adaptive, which means it will look at where the geometry is, and it will place more probes close to the walls and less probes where it's an open space. It will do even more than this, because it's not using collision, but it's really using a kind of SDF, like signed distance field representation of the world. So it can even know if a probe is inside a wall, you know, and if you have a probe inside a wall, it could create some leaks and stuff like that. Here it will invalidate the probes inside the walls. And if you have a probe which is too close to a wall and could create problems, it will push it back. So that's what we call that's why it's called adaptive probe volumes, because you have this adaptive placement. And then it's not totally automatic, I would say. It's automatic, but it's more than this. It's actually assisted placement. So for example, you can place another probe volume on the scene and say you want a different density here, you know, because for example, you have your world, which is pretty large, but most of the things are taking place in one place and the rest is just for the background. You can decide that in this place of the world, I want a higher density of probes. And then on the one, like further away, a lower density of probes. And you just place a volume and then it will bake it for you. Still adaptively, but with just more density. You always have, in any kind of automatic placement, you still have some issues sometimes with a probe kind of fighting a wall, depending on how you bake your level. So you can even add touch-up volumes, for example, that will force the probes to be pushed from that wall, you know? So it's really like a way, once you assist it, then each time you iterate on your world, the probes are automatically placed and automatically baked. Wow. And so it's really cool. And the second thing is like it's probes. Because they are in a very regular structure in the world, they are very fast to bake. So, for example, in the Fantasy Kingdom demo that we showed at the keynote, like the world is huge, right? And we actually were working on it the day before to do the night lighting. And the baking was like 6 minutes, something like this, for the entire world to place all the probes in the world. So it's really, really fast. You know, with light maps, it would take a long time. So that's really what adaptive probe volumes are. Maybe I touch very quickly on why probes look better than light probes. You know, the adaptive probes look better. It's just that it does per pixel lighting, which means that like the probes, the light probes that we have, you have an object, and we will just sample like the 3 probes around it. That's a classic probes, and we will look at the color of the probes, and then we decide. We do an average, and we will decide what's the color of the object in the middle. Here, it's really inside of the shader. We will actually draw the entire object, sampling the adaptive probe volume structure, so that you can have like proper lighting for the objects. So, for example, if you have a big sphere between the red wall and the green wall, and the light is bouncing, when you shade the sphere, when you render each pixel, you will see that there are some probes which are green on the left, so the pixels on the left will be more green, and the pixel on the right will be more red. And because per pixel sampling could be expensive on some low-end devices, on lower-end devices, we also allow to do per vertex sampling. So you still have a nice quality of lighting, but with less things to calculate, basically. You just calculate the per vertex lighting. So still basically you have 3 things you can do. Light probes, you do per object lighting.
Yeah.
And with APVs, you can choose between per vertex or per pixel lighting.
And that's a choice. So you can set one on and one off, basically. Okay,
exactly. You choose if you're where you're sampling the probes, in the vertex shader or in the pixel shader.
Okay. Where pixel might look better, but it's a higher cost.
Exactly. Yeah. And if you have a good density of vertices, like if you have a uniform density of vertices in your world, then actually it will almost look the same with per vertex lighting.
Yeah.
And then like this brings like a lot of benefits as well, because now that it's a structure that we control, because it was not hand placed, you know, we can really add a lot of convenient features on top of it. So for example, we can stream in and out for you the APVs, because we have full control over the full structure, right? So the further away you can just give a budget, and then we will stream out the probes which are not fitting into your memory budget. And then the other thing that it brings also is the fact that, for example, if you have a game which takes place in night or in day, you know, like you have an adventure game and you start during the day and then you come back later in the game and it's the night. Right now, baking these 2 scenarios is kind of complicated. Yeah. You have to do a lot of boilerplates and so on. With APVs, we have stuff called baking sets. So you can create baking sets, and you will define your night baking set, your day baking set. And then when you switch from one to another, you can bake one, or you can bake the other one, or bake all of them. And then switching from a baking set to another one is is quite easy as well. And you can even blend between them. So this requires a compute shader, but you can, for example, blend. You can see it on the bottom left. You can blend. Here we have 12 scenarios which we baked. 12, 2, 4, 6, 7, 8, because the further you go to the evening, the more you need scenarios, because the lighting is changing actually a lot. And then we blend between them, and it creates a day-night cycle, which is very cheap, right? Because it's all pre-baked, but you have the full cycle with a visual fidelity. So yeah, so that's it. And then we have another feature which is coming also together for APVs, is the fact that sometimes you don't want to bake all these scenarios. And what a very nice information is how much that you can store in the probes is how much of the sky you can see directly or indirectly. And so if you cannot see with this, it's called sky occlusion. With that, you will be able to know, like while the sky is changing, you will be able to recompute the indirect lighting dynamically, which kind of simulates a time of day with just one set of probes. So that's it, kind of like very quick. We wanted to do a demo, but we didn't have time, and we hope that probably one of the next one we in the future we do a demo. But there is a great
Amazing.
talk at GDC also if you want to learn more about it.
Which talk is that?
It's called, it's here on the slides, it's called lighting with adaptive probe volumes.
Perfect.
Yeah,
Yes,
efficient and
that's up on our
impactful
YouTube.
lighting. Yeah.
Great. Check that out. I love this feature. You're putting people who place probe volumes out of business with this feature.
I don't think they will mind.
Yeah, exactly. And what I love about this is it works with the reality of game dev, which is a non-linear process where, you know, you might do the level design, then you put in the lighting to see how the game looks, and you'll go all the way to create a vertical slice. But then, you know, you adapt. You do another pass on the level design, and you need it to change. And then there's a series of a domino effect of things you need to do. You have to reposition the lights, reposition the probes, but this adapts to the real workflow of game development.
Exactly.
Which is why it's such a great
Yeah, that's why it's
design.
also like such an important feature for us for Unity 6. So like because it really gives you so much flexibility and also runs like on lower end devices. So not only like on top end devices to achieve like a global illumination look, but really like combined with other features, you can really achieve like nice visuals with it, like also on the wide range of platforms.
Yeah,
amazing.
And it's and you know, like if you have to manage indirect global illumination, indirect illumination, so global illumination in a game, most games that you do need to run on a quite, even if you do just a PC and console game, usually you need to reach users who cannot pay for like real-time global illumination. You know, like in HDRP we have screen space GI, we have ray trace GI, but then the moment you have one, like a group of players or half of your players won't be able to afford it, you will need a way for them to get it, you know? And
Right.
That's why adaptive probe volumes is great, because it's a practical way of authoring indirect lighting that really scales on a wide range and gives you the super good visual fidelity, you know, that you expect. So that's really that. And it's the same for the two pipelines as well. You know, it's compatible with URP and with HDRP, and it has its own particularities on each pipeline. So on URP, you have per vertex lighting, for example. On HDRP, for example, the fog of HDRP will be sampling the adaptive probe volumes to light the fog. It will be a fallback so that screen space GI is a bit cheaper if you want to still have some dynamic global illumination. It can be used as a fallback for ray tracing. So it's really integrated here in both pipelines. I think that kind of represents a vision of how we want the two pipelines to work.
I was just gonna say, this is a perfect example, a proof point of like the philosophy going forward.
Exactly.
Yeah. Beautiful. Thank you. That was very concise, very clear, and it's great to have some of these visuals alongside. And again, if you want more detail, check out the GDC talk lighting with adaptive probe volumes, which is up on our YouTube. We'll drop a link to it in the chat as well. And so thank you, Matthew. The last thing we're going to go over now is the render graph. So Jonas, if you want to, we can jump back to your screen and you can give us just a quick, so what is, you will walk us through just what is render graph and what you're going to show us.
Yeah, I
I
think
can maybe-
actually Oliver should
Oliver, sorry, go ahead.
No, it's fine. Like we can also directly jump in like really quick. But we saw like already like in the other example of fog, like that really extending Unity and especially URP is critical. But what's also important to keep performance. So we often refer to performance by default. But of course, like the more you extend the rendering, the less control we as Unity have or what's going on the screen. Sorry. And but that's really important. Like out of the box, URP is super optimized to run also on low end phones and everything. We have control over our own effects like bloom or whatever. But as soon as you create custom passes or custom renderer features like we saw before, and probably even ones where you use more different textures, where you sample textures and write or read from them, we have to be much more conservative like on the performance, because we don't know what the custom effects use, which buffer, so we can clear less of these. And this is especially then not so good on like mobile GPUs, where you have like a tiling of your screen into many small tiles that are rendered after each other. Because as soon as they need to bring textures in and out from memory, it's really bad for the memory consumption. It's really bad for the battery and for the heat of the device. So you will see that you consume much more energy than you should, because it's like an expensive operation on mobile to really load these textures. And that's why we introduced like a render graph now with Unity 6. So that that we basically learn from your effect which textures or which buffers it uses, so that we understand where can we optimize the things, so that you can still get like best performance and get the memory allocation basically, or the memory bandwidth really down, so that we have an optimal footprint basically of your custom effects. And also for this, we had to like really adjust like the API a little of how you extend the renderer here. And that's what Jonas is now going to show, like how will it look like, what's like the changes, and how it's easier to extend it. And it also comes like with a new context container class, so it's much easier to access all these resources from your frame. And yeah, I think that's really important. And it's also not only about battery consumption, but also like the devices, when you generate too much heat, they will clock you down, so that you are not consuming so much energy, so you lose basically performance. And yeah, with render graph, you can like create custom extensions or can get them from the asset store. And you can be sure that they are performant by default directly, and the render graph auto optimizes the resources.
Yeah, it fixes a problem, you know, like when you write a render pipeline, it's just a big file where you hard code, you know, I'm doing this and then I'm doing that and then I'm doing this. And then like when you have an engine like Unity where people customize it in many places, like each time we want to change something in this order, then you would break everybody, you know, like, oh, now I'm going to move it here. And then everybody assumed that you were doing this in this order. And even in your own pipeline, you might change orders of things and then you have to rethink the entire thing. So the render graph is really here to replace that big description of what the order of things will be with something that you just make contracts on your render graph, and then we will recreate all the right orders for you and manage the resources.
Yeah, and what's then also nice, you have like this debug viewer where you see really visually what's going on, like which path is using which texture and when, in which order, and then you can really understand like how the renderer works without like jumping through the code or reading through the C# code of URP, but really get it visual. And then also when you extend it, you understand where the textures are used and maybe where your performance going down. And then you can also see like how render graph is then merging the passes and calling the native passes of the different devices.
Yeah, now I'm just gonna do a quick example here. So for the sake of time, I'm gonna do it a bit less in depth than I had planned. But we are adding to the sample this pause menu, which I've started making here. It's not very pretty at this point, but it's what it looks like. It just has a sensitivity slider. It's gonna probably be different, but what I wanted to do is add a nice background to this panel here, and I kind of had this idea of doing a frosted glass, so kind of like a very blurred representation of nice. What is behind the pause menu. I'm not gonna be able to build the entire thing. I do have one TV trick, which is I think I should have one that's working somewhere. But I'll just start off and then see how quick I can go through this. Yeah. So it's going to start similar to the post-processing effect, but instead of being this combination of feature and volume, it's just going to be the feature. And I'll just talk a bit about what's in this template here. So for anyone who's built render features in URP before, you'll be familiar with this, but what you won't probably be familiar with is this function here, which is the record render graph function. And as someone who writes passes quite often for URP, I really love this new API. So before and on this bottom section, you had to override these functions here, and it was not as flexible, I would say. It was harder to understand. It was harder to get a grip of the API, and I think this new API is much nicer designed. It's much leaner, and it's also much more confined to make sure that what you're doing is actually supported. by the pass. So this record render graph is the function you want to override. It gives you the render graph itself, and then this context container that Oliver also talked about, which is godsend. And then when you write your pass, or you just do this add raster render pass call. There are a couple of different types of passes, and the raster pass it covers the case where you're just rendering directly to a single target, which is a very common case. And it also is the case that we're able to optimize the most. So this is what's cool about this API, is that we can add different passes and then expose different API and make sure that what you're doing is actually optimal. And then I guess as what I will do, just as a very short example, is I'm just going to try to split the screen contents to an off-screen texture. That's the only thing that we're going to do. So what I need is I will need to set the render attachment of the texture, or of the pass, sorry, to be this off-screen texture that I'm going to create. So I'm going to start by creating it. I'm going to need a texture handle, which is the render graph representation of textures. We have a lot of different representation for render textures and targets in Unity, but this is the one that you should care about now that the render graph is here. And it's nice to be able to just care about this. Now I'm gonna call this the blur buffer for now, and there are a lot of helpers, and knowing about these helpers is of course useful. And you can see that we try to just add some comments in here to make sure that you have some place to start, and you're gonna see me write a lot of this stuff. So right now we're here, right? I'm gonna use the universal renderer.create render graph utility.
Yeah, and in the forum there is already a discussion going on render graph, so there's a lot of active users. So maybe we can link this also later, or I can send it to Hasan so that we can people can also be active there. Just give us feedback also, or we will try to help you on porting effects. Or that's also important.
Yeah, please send it my way. I'll drop the link in the chat.
Cool. Yeah, and this create render graph texture function, it needs a render texture descriptor, which is just gonna contain information about the resolution of the texture and what kind of color it's gonna have, like the graphics type, and we're gonna get that from just the active camera. So this is where we're gonna use the context container that Oliver talked about. And it's super easy. What we need is the universal camera data, which is a class, that contains this camera target descriptor. So this is the descriptor that's for the current camera. That's what we want to reuse for this off-screen texture. And then getting the camera data is very easy. It's just calling this frame data, which is the context container.get. We just say, please provide us with the universal camera data. And this, we now have a copy of this. And this will of course have the descriptor. Like this. Now this descriptor, or the main camera target, has depth of course, and we don't want that for this pass. It's just gonna be a pure color pass, or pure color texture. So I'll just set this to 0, and now I can provide it to the create render graph function here, and we don't need to. I'll give it a name. It's gonna be blur buffer, and we don't need to clear it. And let's use the bilinear filtering. All right. So now we have the actual texture, and as Oliver said, what's cool about render graph is that we can explicitly tell URP what the dependencies are and what resources we need. And you do that by making calls to the builder. So the builder is basically where you set all your metadata of the pass. So I'll call the builder, and then you'll see that it has this set render attachment. And this is basically just telling render graph, okay, for this pass, please render everything into this blur buffer here. Now I'm just gonna. And if I didn't do this, then render graph wouldn't know where to render stuff, and it wouldn't know if it needed the texture or not. So you basically have to do this. Now the next thing is, what are we gonna be rendering from? So that's where we need the current color at this point in the pipeline. And this also brings me to this execute pass function here. So you can see, as we talked about, add render pass. you're giving a builder, and you start setting up your metadata for your pass, and then you also set the render function. And the render function in this case is just calling this execute pass. So we're gonna put all our rendering logic in here, and you can see that we are giving this data, this pass data class called data. And this is also provided. It's outed here from the call to the add raster render pass. And this is where we have to put any data that's going to be used for the rendering logic. We have to put it in here. So, and it's not like this is just a class that's private to this specific pass. So this is where we put that data. And this is where we want to have a texture handle to basically the source for this split that we're going to do in a moment. So I'm just going to do public texture handle source. And then we of course need to get the texture, and similar to the camera data, we're gonna get this from the resource data, the universal resource data. And this is a new class that basically houses every single texture that's used by URP. We get it using the frame data again, and it's so great. Resource data. And we can see here in the resource data, we have basically everything. We have the active color texture, which is the one that we care about right now. But we also have, like, we have depth texture. We have the normals texture. We also have the decal buffers. We have the G buffer if we're running deferred rendering. We have stuff like shadow textures, which we can then set as the target, render stuff into. We also have SSAO. So if we want to add our own SSAO, we can even do that with this and just basically override what's in URP's SSAO texture.
Yeah, it's great to see Jonas excited about the new API. So that proves already a point.
I really like it. It makes a lot of stuff way easier. Now, I'm gonna then this pass data, which was given to me by the add raster pass function, I'm gonna set the source to be this resource data active color texture. So just passing it, saying this is what I want to copy from when I'm gonna copy to this new texture that I've built out down here called the blur buffer. And then again, we always have, for every single resource, we need to be explicit to RenderGraph about what the dependency is. So I'm just gonna tell RenderGraph by calling to this builder that I'm gonna use this texture that I just fetched from the resource data. So the RenderGraph knows, okay, I need to keep the active color alive for this pass. So now at this point, we should be able to just do a quick blit. Probably need a material. So let me just do a quick static one here. Public static material. Let's call it mad. Public static, and then I'm just gonna okay. Load as a pad. This is a bit dirty, but let's do it. Oops. I need to find a material. I have some materials prepared here, so let's just take this, copy path. Load asset add path, and it's a material. So now we are ready to blit. And for this, we also have a helper called the blitter. So I blit the texture here, and I'm just gonna give it the command buffer. And for anyone who's used to writing graphics code, you're familiar with the command buffer. Now, what's cool about RenderGraph is, and what I said about the API being safe, is that this RenderGraph context has a command buffer, and it's a raster command buffer. So it basically ensures that any call that you're making is a safe call. It's something that's okay to do, and it'll not break any optimization that RenderGraph can do. We are gonna grab blit from this source texture, which is the screen texture that I passed by using the pass data. Then just some uninteresting scale bias, and here we put in the material, which is called at.
Peter in the chat says, why not add a copy function to the blitter?
Yeah, so we are actually working on this. So we have a developer working on making utility passes, basically. So instead of having to do this, if you just want to copy to an off screen, it'll be like a single call. It'll be a single call that contains all this. So on your record render graph, you'll just be able to do a call and provide it with the texture where you want to copy. So it is coming. It's I guess it's like the next step.
We first needed to land the APIs so that we made sure that they land properly in Unity 6 and everything. So, and then like the utilities are basically next once we had the foundation laid out and had everything that we needed as an API level, like on the foundational level, we can now add like all the helper function that we need to avoid like all the boilerplate code. So it's very, very good advice here that we are working on it. So it's really important.
Yeah. And just as a very simple effect, I'm just gonna, to make sure that we know that it works, I'm gonna make sure that I get the split texture, and then I'm just gonna filter it really quickly so we only get the red color. So if we see the screen with a red color, then something is working. And of course, I also need to add it to the renderer. So here on my renderer list where we added the fog previously, I'm gonna add this blur buffer. Hopefully it doesn't explode. And now I can take the frame debugger, and what we should see is that I think I put it in after Skybox, but it's not here. There's actually a good reason for that. That's because render graph is doing its job and optimizing the pass away. Because imagine what we're doing right now is that we're copying from the screen to this off-screen texture, but then we never use it. We never sample it to from anything that ends back up on screen. It's not used by any later pass in the render graph. And I can prove that to you by going into the analysis. This is the render graph viewer that Oliver also mentioned. I just want to make sure that I'm looking at the correct texture, the graph. So here we see it, and here this is also amazing. This is an overview, and you can see all out here we have all the different resources, texture resources that are used by URP, and then up here we have every single pass, and of course there's a lot of passes. And then we can see for every single pass, how is this resource bound to this pass. So if it's red, it means that it has write access. If it's green, it means that it's only needs to read from this texture. And then we have our custom render pass here, which is black because it's being called. And that's render graph doing its job, realizing, okay, this pass is actually never needed, so I'm not going to bother rendering it. Of course, for testing stuff, that's not great. So we have this nice handy call we can do to the builder.
Yeah, and before render graph, we basically did not know what's happening. So we were like disabling all the optimizations, which, as I mentioned, was already bad, like on a lot of devices. So here it's really like it knows, okay, it's not needed. It does not use any textures or so. So I don't need to be slower than before, basically.
Yeah. And then what you can do to bypass this, in the case that you don't want to rely on it, is that you can just explicitly set this allow pass calling to be off, and that should mean that we now, after the skybox, see weird. Oh, custom render pass. There it is. Couldn't see it. So now we are rendering into this texture that we created with the red color that's never going anywhere. So I guess I could already now go into this so for this panel here. Yeah, so this shader here is for the background panel, and what I guess I can't. Okay, I'm gonna go to the finished script. So I'm gonna open here. So this is a bit more complicated, and I think this makes sense to maybe do a video about how to get from where we were to this bit. It has a bit more stuff, but mainly what it's doing, instead of using the raster pass that I introduced before, is using an unsafe pass instead. And what this allows me to do is it allows me to use this set render target call, and then I'm basically free to do whatever I want in my pass. And what I'm doing is that I'm creating a series of smaller texture. You can see instead of just creating the single texture with create render graph texture, I'm actually looping from this hard-coded int. I'm looping six times, And each time I'm creating and adding a texture to an array, that's getting smaller and smaller. So every time I decrease the size of the texture to half. And then after I have all these textures, in the actual execute pass, which we had before, I'm doing 2 loops. One where I'm blitting. I start by blitting from the screen, like copying as we saw before, copying into the largest blur texture, and then copying repeatedly down using this shader that's and this is basically called a Kawashi blur. So I have some specific shaders here that samples in a specific pattern with some pixel offsets. And that pattern, if I then first scale it down and then go back up, is gonna hopefully give me a blur. So let's see if it works. I should be able to go into my high renderer here, and let's remove this one and add the working blur buffer. See what the frame debugger looks like. Yeah, so here it is. So after this pass, you can see that here we have a series of passes. It starts by just copying the color, and then it becomes smaller and smaller and smaller and smaller and smaller, goes back up, and we have this blurred version of the screen contents, right? And then in the end, I'm setting a global texture. So I'm setting this blur buffer texture to the full resolution blur. And I can then, inside this pass where I have it set as a global, I can then sample that texture. Right now it's just this hard-coded color, but if I use this instead, we should see this frosted UI behind the pause menu.
That looks so good.
That's good. Yeah, so this is coming to the sample. It's not there right now. We have to build the actual pause menu and stuff, but I thought it was a good opportunity to build a bit more complex render graph pass, and it's also going to have 2 versions, both the render graph and non-render graph path, so you can see how you would do stuff in the different I guess domains.
Yeah, and the unsafe pass is really like getting like a more responsibility to you then as a developer, because you like lose some of the auto optimization, but you are like a little more free to use, so it's okay to use it. That's why we call it unsafe. It's still like a good opportunity, and it's sometimes faster to port existing effects with this. And it just landed in like our internal developer build here that Jonas is using, but it will also soon be available in the public alpha. And then we will also add documentation to the forum about it, because it's very easy to just get your effect into like the unsafe path, and then from there get it into like a normal raster pass.
Yep. So
Perfect.
Yeah.
Really nice.
Thanks, Jonas. Appreciate that. And we did actually manage, while the stream was going on, to upload the talk from Unite. You may notice the excellent speaker. You may recognize them. I'm going to share that right now in the chat. I think we just got that. Can you give us a bit more context to what we discussed in that talk, Matthew?
Yeah, so I guess, Matthew, you had a section about a lot of the features, right? The feature set.
Yeah, there was a section about the feature set, like some of what we discussed today already, and then Jonas demonstrated a lot of the features that we have in 22 LTS and how they work, how we can debug it. So, for example, Forward Plus, we were showing the difference between using Forward Plus or other passes, how to debug your views, and use the rendering debugger also, which is another component which is First Citizen now in both pipelines. We were seeing how to use cookies, light cookies, to fake shadows. There were a lot of tips and tricks going through the samples. So yeah,
I guess a bit about, so in the Oasis we have like this pretty simple ray traced reflection as well. So ray trace reflection, as most of you probably know, isn't let me see, isn't available in URP.
Okay.
So but then we just, for this water shader down here, we did did a very simple one that's just a simple mirror reflection that just ray matches the depth buffer, and I talked a bit about that and showed the code, and that's something we want to do as well. Just use, there's like a lot of stuff in here that we can use for tutorials or use for technical rundowns and guides and stuff. So
yeah, and it's already like it's a lot of, most of it is using shader graph as well, like having a custom reflection system, planar reflection system, almost all made with shader graph. So this is really what we wanted in this cycle, with SRPs, that as a technical artist, you open Unity and you can do a lot of things on your own without requiring to really hack too much into the pipeline.
Yeah.
What we were seeing with render graph is really also like as low as you can get to hack the pipeline. And if you want to go deeper, then you have the source code of the engine. Yeah.
Perfect. Well, thank you all for joining me. Everyone in the chat, thank you for your amazing questions. Really high level questions. You kept us on our toes. I like that. And people are asking, they said they love the stream and they want to see the more regular streams. And we pretty much stream every week. And we'll definitely have these folks back on to talk more graphic stuff. I saw a lot of requests for a stream on the Fantasy Kingdom demo as well. So potentially that's something we can do in the future. Definitely very much in demand. So we'll look at that. We're planning to have a Mega City demo down the line. And next week we're going to be looking at we'll be doing another creator spotlight with Enigma of Fear. So that we're going to open up that game, look in editor, look at how that game is made. So make sure to subscribe and follow on YouTube, follow us on Twitch to get notified when we go live, and we'll see you soon. Thanks again, everyone.
Thanks.
Thanks.
Bye.
Ciao. Bye-bye.
Bye.